This question states, for an element with plane strain of epsilon x equal to 20 microstrain, epsilon y equal to 15 microstrain, gamma xy equal to 5 microstrain, use Mohr's circle to find the absolute maximum shear strain. Well, for this problem, let's go ahead and write out the state of stress from the start. And we have that epsilon x is going to be equal to the 20 microstrain. Epsilon y is equal to 15 microstrain, and gamma xy is equal to 5 microstrain. And you may be saying these numbers are very similar to what we had in the last problem, and yes, they are. They're the same. Here, since we're dealing with absolute maximum shear strain, let's also further clarify that epsilon z is going to be equal to 0. Uh, Gamma xz is going to be equal to gamma yz, and both of those quantities are also going to be equal to 0. So now we've described the state of stress in 3D. Well, we did this in the last example where we calculated out the radius, at least in the xy plane for Mohr's circle. So that comes from, and we also calculated the average location. So using those values, and you can go back if you like to the previous video, what you'll find is that the epsilon, whoa, that's very thick. That's kind of fun. Let's go ahead and change that. Okay, maybe down to there, and let's do that. Okay, so the epsilon average, the center of the Mohr circle, that we determined, well, that's the average. That was at 17.5 microstrain. Okay, and we also determined that the radius, using Pythagorean's theorem with the opposite and adjacent sides, that came out to be a value of 3.16 microstrain. So the Mohr circle for that plane, maybe we'll go back to this, okay, was something like having a center at a distance. Why did I do it like that? I should have put it at the top. Oh, and I'm going to do sigma because we've done so many more circles. Epsilon average, just like that. And then we have a circle with a radius, okay, and we'll say it's modest in size. And we calculated out that this epsilon 1 would be the principal strain. And if you go back to that example, you'll see that epsilon 1 was 20.66 10 to the minus 6, or 20.7 approximately microstrain. We said that epsilon 2 would be over here, like that, okay? And we have that epsilon z, okay, over here, epsilon z is equal to 0. So that means that we're just going to have an epsilon 3 that's also equal to 0. So this is going to be epsilon 3, and epsilon 3 is equal to 0. So the other Mohr circles that we can draw would be going between the z and between the 3 and the 2, really, because we started off with one state of stress, okay, and so now maybe we rotated, right? We rotated about z to get a new x and y where these points were, okay, or a 1 and a 2, right? So this is epsilon 1, or this one's 1, this is 2, right? So we have a, and this is not to scale, okay? Because, for example, this would be 0, this is 17 and a half out here. So this is pretty, way far. This radius should be significantly bigger. And then we have this radius that goes around between 1 and 3, like that. So the absolute max shear strain is going to be down here. And that's going to be an absolute max divided by 2. That will equal to the radius, and we can call it maybe 1, 3. Well, what is the radius 1, 3? That's going to be equal to half. So we have our epsilon 1, okay, which is 20.66. So half of that, or epsilon 1 minus epsilon 3 is just half of 20.66. So that comes out to be something like 10.33 microstrain. So we can say that this is 10.33 microstrain, and therefore what we get for the actual absolute maximum shear strain is going to be twice it again. So that's going to be 20.66 times 10 to the minus 6 microstrain. So in answering the question, what is the absolute maximum shear strain? That is this value that we've calculated here. I hope you have found this example useful. Thank you.